Hello, this is lesson 5.7. We are going to model using exponential and logarithmic functions. And the first thing we're going to talk about is coffee. You can perform an experiment when you measure the temperature of coffee in minutes after it's poured into a cup. So the temperature of a coffee is initially about 185 degrees Fahrenheit. After about 5 minutes, the temperature of the coffee is about 150 degrees. So that is after 5 minutes. Can you use the model in the form of y equals ab to the power of x? That is going to be either a growth or a decay. Can you use that to model the situation? So here's what I want you to do. I want you to really think about what is that going to look like. We're going to use a first quadrant type graph here. So this is going to be time, and then this is obviously going to be the temperature. What do you think that temperature is going to look like if you graphed it? So pause the video, think about it for a second, draw it on your dry erase board if you have one, or a piece of paper, and let's see what you get. All right, so a really popular graph that I keep seeing from students is it will start up here, that's going to be 185 degrees, and then it just kind of gradually decreases. So you can have something like this, which means it's got a consistent decrease. It's not going to do that. It's actually going to have a decay. But what happens is that students will like to do this right here. They wanted to kind of do this kind of motion right here. And I always ask them, I'm like, well, what is this value right here on the temperature level? Wouldn't that be 0 degrees Fahrenheit? So if this is 185 degrees, then that'd be 0 degrees. So if you go all the way down to the x-axis, it's basically going to be 0 degrees Fahrenheit. It's going to be frozen coffee. And last time we checked, if you set coffee on a countertop, it's not going to freeze unless you put it in the freezer. So it's not going to go all the way down to 0. We did say after about 5 minutes, it hits about 150 degrees. So we can have something like this, but eventually what it's going to do is it's going to level off, and that's going to be room temperature. So basically anything that you have like sitting down and it's going to cool off gradually, it's not going to be a straight line, it'll be a curve, but that asymptote is going to be like that room temperature, whatever the room temperature is. So this is what it's going to look like. It's not going to be able to fit this exact form because this exact form will go all the way to the x-axis. So that is out. What you'll have to do is you'll have to adjust it to whatever that room temperature would be. So that is how you answer the first question. Okay, so we're going to talk about something that we haven't talked about yet. We could have talked about these three things right here in chapters 1, 2, and 3. And then this last one, of course, is going to be chapter 5, but I'm going to show them to you now. They're called finite differences if you're talking about linear, quadratic, or cubic. So the easiest thing for me to do is just kind of show you how this works. So the first thing you want to do, and in your notes it says, are the inputs equally spaced? So if you look at each input, it looks like there is a gap of 2, plus 2, plus 2, plus 2, plus 2. So all of these, you are adding 2 to each input. So it's really important that you notice that first. So then you can go ahead and graduate to step number 2. So step number 2 is that we are going to check the y values, okay? Checking the y values to see if any of the first, second, or the third differences are the same. What in the heck is a first difference? Well, what you're going to do is you're going to figure out exactly what you did before. What is the difference between each of your y values this time? So what are we adding to 1 to get to 8? Or negative 1, sorry. So you add a positive 9 to get 8. 8 plus negative 1 is 7. 7 plus negative 5 is 2. 2 plus negative 3 is negative 1. This is going to be plus negative 5. That is not right. That's going to be positive 5. Okay, and the last one is going to actually increase by 19. Okay, so this is what we call the first difference. If these numbers were the same, this would be considered linear. They are not linear. So what we're going to do is we're going to check something called the second difference. So between each one of these numbers, we are adding a particular number. So I'm going to go through here and I'm going to fill that out. And let's see if these are the same. Okay, so if these were the same, and they are not, this would be considered quadratic. And all of these are listed up here. So first difference, linear, second is quadratic, third is cubic. So let's try it one more time. Let's go for that third difference and see if these are the same. So it looks like what we're doing is we are adding 6. And guess what? We finally made it work. So the third difference is the same. That means that this is going to be cubic when you graph that. And remember, cubic has that either up coaster or a down coaster kind of look to it. So that's how you identify it. If it's not if it's not a first or second or third difference, you can check to see if it's exponential. So if you look at the second one over here, exponential means that you're multiplying the same amount. And that is called your common ratio. And a lot of times you can tell that with kind of like these numbers right here. Notice I'm not adding the same number here, so I'm going to look. I definitely see a pattern here. Like I know this is times 2 times 2. So if you can establish that you're not adding, that you are actually multiplying the same amount, then you can go ahead and just stop because you have a common ratio. And it's not going to be a first, second, or third difference. So your common ratio is 2, which means it is exponential. And that's all you're doing. You're not trying to write a function or graph it or anything like that. You're just trying to figure out if there is a pattern in the data and what pattern or what function would this data create. Okay, so this is on the next page. If you look at this one, you can go ahead and try to see if it has a common ratio. I can't really tell at the moment, but I'm going to go ahead and see if we have a first or second or third difference. So it looks like we are adding a -3, adding a -3, adding a -3. Okay, well that was pretty easy. So the first difference was the same, and if they are the same, then this means that this is linear. So that's what a linear equation is going to look like. Okay, over here, I can clearly see that there's a pattern. If my app will behave. I can see that there's a pattern here. So 29, looks like it's divided by 3, doesn't it? The problem is if I have a common ratio, you have to multiply by a certain number. Well, all you have to do is take the second number right here, this 9, and divide it by the first number. And that should give you a common ratio if there is one. So that would be 1/3. So does this work? Is 27 times 1/3 9? Yes. Okay, does it continue in the same pattern? So 9 times 1/3, is that 3? Yes. Same thing, you got to make sure they're all going to be in that pattern. So 3 times 1/3 is 1. So you have a common ratio of 1/3. Which means this is exponential. So in this next part, if you ever want to actually write the model, you can actually use 2 of these coordinates and follow these 3 steps, and you will actually have your model written. So what we're going to do is we're going to label each one of these x and y. And we're going to use this form right here. It doesn't matter if it's a growth or decay, it will work. You're going to write 2 equations. So the first equation, you're going to substitute x is 1 and 6 is y. So I'm going to put 6 equals ab to the power of 1. And in the second equation, I'm going to use 3 and 54. So I'm going to do 54 equals ab to the power of 3. So what we're going to do is we're going to solve for a in equation 1. So we're going to write it down. This is b to the first power, so I'm going to divide by b. Sometimes that power will change. So I have a equals 6 over b. What you're going to do is you're going to take that and you're going to plug it in. You're going to substitute it into that second equation. So I'm going to write 54 equals a, b to the third, but underneath it, I'm going to replace a with 6 over b. And what's going to happen is that your b to the power of 3 is going to cancel with b to the power of 1. So if you've got 3 in the top, 1 in the bottom, it's going to replace it with b squared. So we have 54 equals 6b squared. Go ahead and solve for b. So it'll be 9 equals b squared, and then you have to take square root of both sides. And it's got to be positive. Your base in an exponential function always has to be positive, so b is positive 3. So now what you do is you take this 3, and you're going to take it and you're going to plug it back into what you solved for a. So now a is 6 divided by 3, which is 2. So you have enough information to figure out step 3. All you have to do is plug back in the a and the b. So y equals 2, b is 3, and then you got power to the x. So you know it's definitely going to be a growth. Start at 2, and you are multiplying each value by 3. All right, let's take a look at the second one. So this is x and y. I'm going to use this one for equation number 1. So I'm going to write, instead of y equals abx, I'm going to substitute y is 2 and x is 1. And I'll change colors over here. So same thing, y equals abx, y is 32, and x is 3. So I'm going to take this first one and I'm going to solve for a. So that means I divide both sides by b. So a is equal to 2 over b. Now I kind of don't have a lot of room over here, so I'm going to write the second equation. And I'm going to substitute 2 over b for the a. All right, so same thing kind of happens. The b to the power of 3 and the b to the first power, they cancel out, and that leaves me with b squared. So I have 32 equals b squared. Oop, I forgot the 2. So 2b squared, divide each side by 2. I get 16 equals b squared, and if you take the square root of both sides, b has to be positive, so I know that b is 4. You got to take that and you got to plug it right back into what you had for a, so that is now going to be 2 divided by 4 equals a, so a is going to be 1/2. Okay, last step, you're going to take your a and your b and substitute it back into that generic form here. So a is 1/2 and b is 4, and it'll be to the power of x. And I think that's going to do it for this video. You don't have to worry about this one, and just let me know if you have any questions.